Welcome back to the second lesson of Professor Roberto Araújo Lima's PLC course. Today, we'll be focusing on the connections of digital and analog inputs and outputs in PLC systems. We'll learn how to properly connect these components to ensure reliable and accurate operation, as well as how to diagnose and troubleshoot any connection issues that may arise. So let's get started and gain a deeper understanding of how to properly connect digital and analog inputs and outputs in PLC systems. As always, feel free to reach out if you have any questions or need assistance throughout your learning journey. We're here to help you gain a comprehensive understanding of PLC systems and how to work with them effectively. Digital inputs are used to sense discrete states such as on-off or true-false in a PLC system. They can be connected to various devices and components such as switches, sensors, and push buttons. The voltage levels of digital inputs in PLCs typically range from 24 to 120 volts DC or AC, depending on the specific PLC model and the type of input module being used. Some digital input modules may also include features such as filtering or noise suppression to help reduce interference and improve the reliability of the input signals. Digital inputs are essential components of PLC systems, as they allow the PLC to sense the status of various devices and components in the system and use that information to execute control logic. In the next lesson, we'll explore how to program digital inputs and outputs in PLCs.
Note logic levels 1 and 0. They are related to the value of the electrical voltage that arrives at the corresponding digital input. In this example, logic level 1 corresponds to a value of 24 volts, while logic level 0 corresponds to a value of 0 volts. It is important to understand this way of interpreting digital input signals, as the PLC only understands logic levels in its digital inputs and outputs. The connection of digital inputs in the plug-and-play or sync input format is a format widely used by manufacturers. Note that the digital input card is being supplied with voltage from the power supply. The elements that will provide level 1 and 0 logic signals are connected to the corresponding digital highways. Note that the positive of the power supply is the signal that interconnects the components, such as the normally closed button S0, the normally opened button S1 and the sensor S2. In the case of button S0, the digital input to which it is connected is already receiving level logical 1. When pressing the button, its contact opens and the digital input goes to level 0. As for the normally opened button S1, the digital input to which it is connected is at level 0. When pressing the button, its contact closes, and the digital input to which it is connected goes to logic level 1. In this example, the connected sensor can be inductive, capacitive, optical, but the main thing is that it is a plug-and-play sensor, because when it changes state it will send the positive signal to the PLC input. Thus, the sensor has the same behavior as the buttons, sending logical level 0 or 1, depending on the detection of the object in its detection region. In this example we have a plug-and-play capacitive proximity sensor, connected to digital input I03 of the PLC. The brown wire of the sensor is connected to the positive of the power supply, the blue wire is connected to the negative of the source, and finally the black wire, responsible for sending the signal to the PLC. This signal is the positive of the source. If the sensor detects an object in its detection region, its signal will change. Then the black wire will send the positive signal from the source to input I03.
NPN inputs, also known as source inputs, are the opposite of PNP inputs. In an NPN input, current flows from the negative side of the power supply to the load. When the input is activated, current flows from the negative voltage source through the input and to the positive voltage source of the PLC. To connect an NPN input to a digital input on a PLC, the wiring scheme would be similar to that of a PNP input, except that the positive power supply wire would be connected to the positive voltage source of the PLC, and the negative power supply wire would be connected to the input. Again, it's essential to consult the documentation for both the sensor and the PLC to ensure proper wiring and compatibility. As with PNP inputs, different PLC models and manufacturers may have specific requirements or recommendations for connecting and configuring NPN inputs, so it's always a good idea to check the documentation for your specific PLC model.
Note that in this example we have the negative power supply wire passing between the button S0, S1 and the sensor S2, which in this case is an NPN sensor. The logic levels at the inputs continue with the same principle as the plug-and-play inputs. The button connection normally closed S0 is already at logic level 1, when the button is pressed its physical contact opens, and its logic level goes to 0. Likewise the normally open button S1, where its connection with the PLC digital input, is at level logic 0, and when the button is pressed it goes to logic level 1. The NPN sensor, when its state is switched, sends logic level 1 to the corresponding digital input. Observe the connection of the normally open pulse button to the I/O3 input of the PLC. Note that the connection is now NPN, as the wire that is connected to the negative of the source is the one that passes between the button and the I/O3 input. In a similar way we have the connection of the capacitive sensor in this next example. Note that the sensor must be of the NPN type, and when the sensor detects the presence of an object, the negative signal from the power supply reaches input I/O3 through the black wire of the sensor. Digital outputs. We can connect signals, contactor coils, valve solenoids, electro-pneumatic and electro-hydraulic actuators, among other devices of the machine or process to be controlled, to the digital outputs in direct voltage. Digital output points can be PNP, NPN, dry contact relay.
PLC digital outputs are used to control devices or components in a system. They can be connected to a variety of devices, including signals, contactor coils, valve solenoids, electro-pneumatic, and electro-hydraulic actuators, and more. Using solid-state relays, SSRs with PLC digital outputs, can provide protection against short circuits and other electrical faults, as well as faster and more reliable switching. Connecting devices directly to PLC digital outputs can provide precise and reliable control of a wide range of processes and systems. It's important to choose SSRs and other components that are compatible with the current output of the PLC, and to follow best practices for wiring and safety. Overall, PLC digital outputs are a powerful tool for controlling and automating industrial processes and systems. Analog inputs are used to measure continuous values, such as temperature, pressure, or flow rate. Unlike digital inputs, which can only sense on-off or high-low states, analog inputs can sense a range of values. PLC analog inputs typically have a voltage or current range that they can measure. Some common ranges include 0-10V, 4-20 mA, and 0-20 mA. Analog inputs are often used in process control applications, where precise measurement and control of continuous variables is critical. PLCs can use the input from analog inputs to make decisions and control other devices based on the measured value. For example, a PLC could use an analog input to measure the temperature of a process fluid and then use that information to control a cooling system to maintain the temperature within a specified range. Analog inputs are an essential component of PLC systems, providing the ability to measure and control continuous variables with precision and accuracy.
In this example we have a pressure measurement system. Notice that we have the pressure indicator, to visualize the tank pressure. We also have the pressure transmitter, with the necessary power to transmit the tank pressure value to the PLC, through a current signal from 4 to 20 mA. The connection is made to the CP's analog input, which must be configured later in the programming software.
Sure, let's talk about analog outputs, and how they're used in PLC systems. Analog outputs are used to control devices that require a continuous range of values, such as valve positioners or motor controllers. They can output a range of voltages or currents, similar to analog inputs. Some common ranges include 0-10V and 4-20 mA. Here are some examples of how analog outputs are used in PLC systems. Valve positioner. An analog output could be used to control the position of a pneumatic valve, allowing precise control of flow rate or pressure in a process. Servo motor. An analog output could be used to control the position or speed of a servo motor, enabling precise control of movement in a system. Variable frequency drive. An analog output could be used to control the frequency of a variable frequency drive, which in turn controls the speed of an AC motor. Overall, Analog outputs provide a flexible and powerful way to control continuous variables in PLC systems.
In this video we have an example of an application using the PLC. Note that we have several elements present in the plant, such as sensors and actuators, all controlled through the digital and analog inputs and outputs of the PLC. There is certainly a whole program to interpret these signals, doing so process control. This process separates the pieces by color. In the next video we have the rejected piece. Note that the elevator's analog sensor has detected the part in the wrong position, so it will be separated in a different location. This process was developed by students of Professor Roberto Araújo Lima, at the Sinai School.
Here's a summary of the key points we've covered about digital and analog inputs and outputs in PLC systems. Digital inputs and outputs are used to sense and control discrete states, such as on-off or high-low. Analog inputs and outputs are used to measure and control continuous variables, such as temperature or pressure. Digital inputs are typically connected to switches, sensors, or other devices that produce a discrete output. Digital outputs are typically connected to devices that require a discrete input, such as indicator lights or relay coils. Analog inputs are typically connected to sensors or transducers that produce a continuous output. Analog outputs are typically connected to devices that require a continuous input, such as valve positioners or motor controllers. Digital and analog inputs and outputs are essential components of PLC systems, providing the ability to interface with a wide range of devices and systems. Proper wiring and configuration of these inputs and outputs is critical to ensure accurate and reliable operation of the PLC system. Thank you for watching the video on digital and analog inputs and outputs in PLC systems, developed and reviewed by Professor Roberto Araújo Lima. We hope you found the material informative and engaging. As you continue your journey in learning about PLCs, we invite you to join us for the next lesson on Boolean logical functions applied to PLCs. In this lesson, we'll explore how Boolean logic is used in PLC programming to make decisions and control outputs based on the state of inputs. So please join us for the next lesson and continue to deepen your understanding of PLCs and their applications. We look forward to having you with us. As always, if you have any questions or need assistance, please don't hesitate to reach out. We're here to support you in your learning journey.